We want to talk about the polynomial and the rational functions. First, let's look at the polynomial function. So the polynomial function is given by this form. Y equals f of x. What is f of x? It can be written as a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus and so on. And you continue a1 x to the 1, which is just x, right? Plus a sub 0. So this is the typical form for a polynomial, the general form for the polynomial function. So here we have some information for this function. So this n, the highest power n, is called the degree of this polynomial. And a sub n, a sub n minus 1, a sub n minus 2, and a2, a1, and a sub 0, these are real numbers. Okay, these are real numbers, and which is called the coefficients. Coefficients. That's good. ENTS. Coefficients. And the coefficient for the x to the nth power, this an we give a special name, which is called the leading coefficient, which is the coefficient of the highest power term, leading coefficient. And the domain for this function, the domain is the collection of all x values we can plug in. Actually, we can plug in any number you want. So the domain for a polynomial is always all real numbers. All real numbers. Which means negative infinity to positive infinity or infinity. All real numbers. So now let's look at some special functions. So where we have learned the y equals ax plus b, right? This is a very special polynomial, which is a polynomial with degree 1. With degree 1. And if you have y equals a constant c, this is called a polynomial with degree what? 0. Right? We also have learned a quadratic function, which is ax squared plus bx plus c. So this is a polynomial with degree 2. Okay, so these are the special polynomials we have learned. So now today we want to learn some general polynomials, the information for the general polynomials. So now let's look at some properties of the graph of the polynomial. So here is several cases we want to talk about. if the first case, the degree n is an odd number, just like 1, 3, 5, and so on, odd number. And the leading coefficient a sub n is positive. Then the graph for a polynomial always start from the below of the x-axis, okay, and end above x-axis. So between these two arrows, we don't know the behavior of the curve, okay, but we know which is called the end behavior. When x is very small, then the curve is always below x-axis. Okay, when n is large enough, the curve is always above x-axis. This is called end behavior. So this is the case for a sub n is positive. If n is still odd number, but a sub n is less than 0, negative number, then the behavior, which we just flip the behavior of the first case about x-axis. This is x-axis, right? So it always starts above x-axis and will end below x-axis. And the curve between these two arrows, we don't know. It depends on the problem. Okay, so this is the odd number. If n is an even number, so let's give you an example. You can see that. One example is the y equals f of x equals x cubed. This is the cube function. We already know the curve will look like this one. So you see the curve starts below x-axis and above x-axis. Okay. Another example is fx equals x. Right. So this would be the starts below x-axis and above x-axis. Right? If you have f of x is negative x, so the coefficient, leading coefficient a sub n equals negative 1, less than 0. Start above x-axis and below x-axis. So this is the second case, right? So now let's look at the third case when n is an even number. N is an even number, so the a sub n is positive. Okay, for this case, what is the end behavior? The end behavior is the curve will start above x-axis and end also above x-axis. But between these two arrows, the curve between these two arrows, we don't know the behavior. Okay. And similar thing for n is even number. That's 2, 4, 6, 8, these kind of numbers. And a sub n is less than 0. What is the behavior? We just flip the previous case about x-axis, so which would be this one. So in other words, the curve will start below x-axis and will end below x-axis too. A typical example for this kind of even number, even number degree, and which is f of x is x squared, right? So here a sub n is, so here n equals 2, a sub n equals 1, so greater than 0. So we know the graph, it looks like this one, right? So you can see start above x-axis, end above x-axis, right? So, but we're very curious between these two arrows, right? Between the end behaviors, the curve between end behavior. So here is a very basic rule. You can see that this is another rule which is called the X-Intercepts. The X-Intercepts of the polynomial, sometimes we give a name which is called the zeros or roots of the polynomial. Okay, so the x-intercept of a polynomial is also called the zeros or the roots of a polynomial. So it describes the intersection between the curve and the x-axis. So here is a very basic rule. You will see that suppose we have the degree of a function f of x is n. Then this function f of x will intersect x-axis at most n times. So in other words, if the degree of a function f is n, then the x-intercepts you only have at most n x-intercepts, or n roots, or n zeros, at most n zeros. Okay, so at most means not greater than n, less than and equal to n. Okay, so at most means less than and equal to. So for example, if you have f of x equals x squared plus 2x plus 1, right? And here n equals 2. So we know that the roots or the x-intercepts or the zeros of these functions would be the number of zeros, the number of the x-intercepts would be less than or equal to 2. That means at most 2. So the curve will intersect x-axis at most 2 times. Okay? maybe one time, maybe 0 time. It depends on the problem, but this will never happen. So this is the even, so this is the above x-axis and above x-axis, but this will never happen. Which intersect x-axis 4 times. It is impossible. Impossible. Okay. And we also know that, for example, for this one, for the n is even, if you have the degree of this f of x is odd, and an is odd, okay? So if an is positive, no matter an is positive or an is negative, so here we just say an is positive, so we know it starts from the below x-axis, the above x-axis. So you can see that from below x-axis to above x-axis, this curve will intersect x-axis at least one time. Will intersect x-axis at least one time. Okay, so this is for the case that n is, the degree is an odd number. For the case where the degree is even number, we have no this rule. Okay, this is just for odd. The degree for even, we may have no intersects, right? In other words, we have 0. It will never intersect x-axis. For even number, it may be possible. Okay, but for the odd number, it must intersect at least one time. Okay.